Okay, so this is the continuation of the previous video. The previous video we just proved the integration factor depending on x only, and also depending on what, y only. Please try to subscribe and share to your friends. Now looking at this one, the first thing to do is to test whether it's exact or not. When it's not exact, that's where we call in for the integration factor. So let's test first. So we have this becomes my m in terms of x and y to be this y plus xy squared. Okay, so I'm going to take it. So when I differentiate this one partially with respect to y, I have 1 plus 2xy. And I'm going to have n in terms of x and y. If I also differentiate it, sorry, n is negative x. So if I'm going to differentiate this one with respect to x, I'll have negative 1. So you will notice that this one, delta m delta y is not equals to delta n delta x. So when it's happening like this, then we say that it is not what, exact. So when it is not exact, what do? We need to introduce the integration with factor. We need to introduce the integrating factor. Is that okay? Now, for you to introduce the integration factor, how do you know that this one is dependent on x only or y only, or both x and y? But as I said, for now we are depending on x and y, x only or the y only. So let's see how we test it. Okay, so for you to know, if you remember when we were proving the formula for the y only, we came across this delta n delta x minus delta m delta y all divided by m, right? We came across this one. So first, if you write this formula, this is what is going to give you when it's depending on what, y only. So we come to this place. Delta n delta x is here. Where is it? It's here, negative 1. Delta m delta y is here. So when I come to this place, this one is negative 1, so I have negative 1 minus delta m delta y is 1 plus 2y. So I'm multiplying the negative through. That will give me negative 1 minus 2xy. And the whole of this is dividing by m. This is my m, y plus xy squared. So I have y plus xy squared. So negative 1 is going to give me negative 2, they have negative 2xy, all divided by y plus xy squared. So the common term here is negative 2. That will give us 1 plus xy, and here the common term is y, and this will give us 1 plus xy. Okay, so this will go with this. Then I have negative 2 over what, y. And you see that this one is depending on y only. Okay, because if you look at this one, the only variable there is y, there's no x. That's what we mean depending on y only. Once you have gotten this, it's okay. But you can also use the other one to test. The other one, if you want to test it, once we have y only, we don't need to test that one. Assuming that when we did this and we're having y and x together, that's where we have to use the other way around to test. Okay, but if you want to test the other one, the formula is going to be delta m delta y minus delta n delta x all divided by what? N. And you also test. You will see that one you get both x and y. So that one you have to forget about it. So always make sure that if you test one and you do not get whether y only or x only, then use the other way to also test. Very good. Okay, so at this point, what we have here, remember the formula that we created here, or I wrote to do the substitution. We said that one was equals to, this one is y only, so in terms of it will be p of y. This is x only, so in terms of it will be p of x. If you have watched the previous video, you will see that. So what is happening is that what we have here, once is depending on y only, we can say that this is p of y equals -2 over y. Are we seeing it? But I said that some people, instead of them to write a formula straight, they will start from here in some books. Delta ln mu all divided by, this one is depending on what? Y only, so all divided by y equals -2 over y. Is that okay? So what we are having here is that, sorry, so this is y. So at this point, can do cross multiplication, then I have 2, sorry, delta ln mu equals -2 over y delta y. So at this point, if I take integral on both sides, this one will take care of this. So we have ln mu equals, this one is a function in derivative, so I'm going to have -2 ln y. Is that okay? Remember that if I have integral of this, I can bring the -2 out, leaving the y over y delta y, so that this will be a function in derivative. So after that, the -2 multiplied. I told you the other time. So at this point, I have ln mu equals to ln y to the power -2. This is logarithm, so when a number is here, it can come top here. That's all. Looking at this one, I can take e on both sides, so that e ln mu equals e ln y to the power -2. We are taking e so that the ln will go away. So I have my mu equals to y to the power -2, which is the same as 1 over y squared. So this one becomes my integration what? Factor. So in terms of y equals 1 over y squared. So that becomes my integrating what? Factor. Is that okay? Okay, so now let's look at those that also go by the formula. We said that with the formula, straight away, it is giving us e to the power integral of p of y like this, right? So already you know our p of y to be -2 over y. So this one is going to be e to the power integral of -2 over y. So we have e to the power. So when we did this, you realize that this was a function in derivative, just that I've explained that one already. So we have -2 ln y. So this one will give us e to the power ln y exponent 2. So this and this will cancel, leaving y exponent 2, and this is going to give us 1 over y squared. So that's the integration factor. Now let's look at these two things. If someone passed through this lengthy procedure, the person still arrived at this answer. If you go straight with the formula, you also arrive with the same answer. So it depends on you, the one you want to use. Is that okay? Good. Okay, so at this point, our integration factor is 1 over y squared, right? And if you remember, when I started with the previous video, I told you that after getting the integration factor, you just multiply through this so that we can reduce this one to exact. So let's do that. So 1 over y squared multiplied by y, that will give us what? 1 over y. 1 over y squared multiplied by this, that will give us x, and this is the x, minus 1 over y squared multiplied by this will give us x over y squared, and that is the y, and this is equals to 0. So as usual, our m in terms of x and y is now 1 over y plus x. So delta m delta y is going to give us, now if I differentiate this one, I'll have negative 1 over y squared. This one will go to 0 because I'm doing with respect to y. Then let's take the other one. N in terms of x and y will be giving us x over y squared. So I'm going to take it delta n delta x is equals to, remember there's negative here, so let me bring that negative. Negative x, I'm differentiating with respect to x, so if I differentiate x, I'll get 1, so I'll have negative 1 over this. So at this point, we can say that delta m delta y is equals to delta n delta x, which is equals to negative 1 over y squared. So you see that we are able to reduce it to exact. Now they are the same. So we now follow the normal procedure that we used to solve. Now let's continue. This is our m to be equals to this. This is our n, right? When we are solving exact, if you remember, you just take this one, then we integrate. We take this one, we integrate. That's all. So this one, we know that our m in terms of x and y is equals to 1 over y plus x. Okay, so I want to integrate this one. This m is the same as delta u delta x, which equals to 1 over y plus x, if you remember. So this becomes delta u equals 1 plus y plus x delta x. So I take the integral on both sides, so that I have my u to be equals to x over y plus s squared over 2 plus, if you remember, a function of the other function, other variable, a function of the other variable. Listen, this one we are integrating, so if here's 1, if I integrate with respect to x, I'll have x here, but there's over there, that's why I brought it there. Then x, that will be x squared over 2, and the other function. Now let me clean this side and explain something. Okay, so now let's look at this. This is what I have here. Okay, but we need to find f at y, that function. Remember when we were doing with exacts, when I finish with this, or when I finish integrating the m, then I'll move to the n. But with this, if you do that, there will be a problem, very big problem. Okay, so we have a way of doing it. What you are going to do is that here I integrated the m. Somebody can decide to use the n and do the integration on the n instead of the m. But I've used the n, sorry, the m. So if I've used the m, Then I'm going to do something with this n. But if you use n, then you will do something with the m. So look at what I'm going to do. After getting here, because we want to find this one, it means that I will differentiate this one partially with respect to the function here, which is y. So if I'm differentiating this one, that will be delta u delta y. So I'm taking it with respect to y because of the function here. So the one who will also integrate with respect to n will get a function that is in terms of what? X. So that person will take the partial derivative of it with respect to x. I hope you understand what I'm doing here. Good. So now let's move on. So if I do this, this is with respect to y. So here will give us negative x over y squared, right? Negative x over y squared. This plus the whole of this one will go to 0 because I'm taking partial with respect to y. So this becomes constant, go to 0, plus inverse of y. So you have f prime of what? Y. Is that okay? This function, you can't do anything, so you have to bring prime, that's all. Now after getting this, what we do here is that we are going to equate this one. This one was over y squared. Okay, I've made a mistake. When I multiply the integration factor, I'm supposed to write that one, not this one. This one is what was not exact, but I've multiplied through by integration factor. So when you multiply here by the integration factor, which is y squared, that would have given you 1 over y plus x. Okay, so it's like this. Now what I'm going to do here is that, as I said here, I use the m to get this. So after taking the partial derivative with respect to the function there, then you equate it to the one that you did not use. So if you use this one, after you are done with everything, you equate it to this, meaning that negative x over y squared plus f prime of y is equals to negative x over y squared. The reason is that we are doing all this one in order for us to be able to find the constant, the f of y, this constant. So let's make f prime of y the subject. If I do that, I'm going to have f prime of y to be equals to negative x over this one. I don't even need to write, because if I bring this one here, it becomes 0. So equals to 0. So this is what I have, f prime of y equals 0. So we integrate, and if you integrate f prime of y, it becomes what? Fy equals what? If I integrate 0, it's still 0 plus the constant, which is what? C. Is that okay? So the meaning of it is that when we work for the other one, we have u equals to, I've even cleaned this thing here. Let me check. So we had x over y, okay, plus x squared over 2 plus f at y. So now that we have our f at y, you know, this one is in terms of x and y. Then we are going to have x over y plus x squared over 2 plus what? C. Okay. Yes. So now, because f at y is c, but you know, a place we said that this one can also be 0. So we can equate x over y plus x squared over 2 plus c to 0. So this one becomes our general formula. This becomes our general formula. So when you get here, you equate this one to 0. If you remember the first one we did, the first one, because we don't go with this way of finding the constant. The first one, you should differentiate the n, differentiate the m, then you compare, if you remember. But this one, it doesn't work like that, so take note of it. Okay, now let's move on to next example. Okay, so now let's look at this example. Find the general solution of this. Okay, so first thing, let's check whether it's exact or not. So you identify m and x n. So this is x plus 2y squared. So you take partial with respect to y, and this will give us 4y. Then we take our n. Our n is negative 2xy. So if I take partial with respect to x, I'm going to have negative 2y. Now let's compare these two. These two are not the same. This and that, they are not the same, so they are not exact. Have you seen that? So you need to look for the integration factor. Is that okay? And I hope you remember how to look for the integration factor. Good. So in looking for the integration factor, as I said, first thing, we check whether it depends on y only or x only. So this one is checking whether it's on y only. So delta n, delta x, we have done it here, which is negative 2y. So I have negative 2y. Then you also have delta m, delta y, which is 4y. So negative 4y. And this one is divided by m. Where's our m? This is our m. X plus 2y squared. So we have x plus 2y squared. These two will give us negative 6y, all divided by x plus 2y squared. Now there's no way that we can eliminate this x, so that we have only y. So let's check the x only. And the x only formula is also giving us so now this is x only formula. Delta m, delta y is 4y, so I have 4y minus delta n, delta x is negative 2y, so that will be 2y. And the whole of this one is divided by n. What is our n? Our n is negative 2xy, negative 2xy. So this will give us 6y over negative 2xy. And this will give us 2 goes here. So we have negative 3, y cancel y, all divided by x. So we have negative 3 over x as our integrating what? Sorry, we have negative 3, meaning that it is only depending on x, not y. That's why this place there was still x there. Is that okay? Now, find the integration factor. So this time I'm going to use the formula straight. As I said, this one will be p of what? X, which is equals to negative 3 over x. Is that okay? So I'm going to have mu in terms of x is equals to e integral of p of x. Okay, means that mu equals e integral p of x is negative 3 over x. Okay, so mu E negative 3 ln x. Okay. So the negative 3 will come here, and that's going to give us mu in terms of x equals E ln x to the power negative 3. Is that okay? So this will cancel this, meaning that this will give us 1 over x cubed. So now this becomes our integration what? Factor. This becomes our integration factor. So we are now going to multiply this one through this formula or the equation that was given to us. So we are going to multiply this one through this. Okay. So 1 over x cubed times x will give us x squared. So this will give us 1 over x squared plus 1 over x cubed times this will give us 2y squared over x cubed. And the whole of this one is dx minus 2y over x squared dy. Okay, so if I multiply this one by this, one of the x will cancel this, leaving x squared, and the y is still there. So let's identify our m. Let me write it up here. Our m is now 1 over x squared plus 2y squared over x cubed. Then our n equals negative 2y over x squared. Okay, so this is our m and our n. So first thing, let me take the differential of it, partial 1 over delta y. This one will give you, with respect to x, so everything here will go to 0 because of with respect to y. And this one will give us 4y over x cubed. Then we take this one to delta n all divided by delta x. And if you do that one too, this one will give us 4y over x cubed. Hope you know why. You send the x squared out, that will be negative 2y multiplying by x to the power negative 2. So this time that will be positive 4 and minus 1. That will be minus 3. So when you do that, it will be positive 4 over. That one will come down again. Okay. So for now, we can conclude that delta m delta y is equals to delta n delta x, which is equals to 4y over x cubed. Please, if I do any differentiation or integration you don't understand, you can leave it at the comment section or you test me personally so that I will explain things to you. Okay. So now, this is what we have. Once it's exact, this is what we are going to do. You either pick this one and you integrate, or you pick this one and you integrate. The first one I picked m, so now let me pick n. So I have my n to be equals to negative 2y squared all divided by x squared. But we know that the n is also given as delta u delta y, which is equals to negative 2y squared over x squared. We know that. So okay, so now Now that we have this one, I can write this one as delta u equals negative 2y squared over x squared delta y. So I'm going to integrate it. So integral of delta u equals integral of negative 2y squared x squared delta y. So this one will go with this. So my u is now equals to, I'm integrating this one with respect to y. So what is going to happen here is that if I multiply this one by this, I'll have negative, so this integration, so I'm going to have negative 2y cubed all divided by 3x squared, because that will be over 3, that 3 can come here, plus f at x, because this around I'm doing with respect to y, so the function will be at x. Now that I have this, I have to take the partial derivative of this again. So this will give us delta u, delta, by this time around, because it's in terms of x, I'll take with respect to x, equals to, so now I'm going to differentiate this one. This one will go top there. When it goes top there, become negative 2. So negative 2 times this, that will give us positive 4y cubed, all divided by 3x cubed, like this, plus f prime of x. And we are saying that when you finish with this, we are going to equate this one to the one that we did not use here. So among these two, the one that we did not use is m. Okay, so I'm going to equate 4y cubed over 3x cubed plus f prime of x equals 1 over x squared plus 2y squared over x cubed. Is that okay? So that's what I'm going to do. So now I want to make this one the subject. So I have to send this one here. Is that okay? Alright, so now I think there is a problem here, so let's clarify that. The n is equals to negative 2y over x squared, but here I wrote negative 2y squared. So this side is supposed to be just x. Okay, so here too will be, this side is supposed to be just y, here too will be y. So when that thing happen, here I'm integrating with respect to y. So this side, because it's just y, if I integrate this way, it becomes y squared, not y cubed. Then over 2. So these two will be cancelled with these two, so that here nothing will be hit there, and here will be squared. So this side will be squared. Okay. Now when we differentiate this one, yes, this one become cube. Okay, so now this side nothing will be there. Like this. Okay. So now this is what we have at the y squared over x cubed plus this equals to that. So now let's send this one to this side. If I send this one here, I'm going to have f prime of x equals 1 over x squared plus 2y squared over x cubed minus y squared over x cubed. So now here this and this are the same. So I can subtract this one from this. If I subtract this from this, I'll have y squared. So I'm going to have f prime of x is equals to 1 over x squared plus y squared over x cube. This is what you are going to have. Now you take the integral on both sides so that the f prime, the prime can go. So 1 over x squared plus y squared over x cube. Okay. So we are doing with respect to x. When I do that, here will be f at x equals to negative 1 over x plus, okay, this side will become negative y squared over x cube two x squared plus c. Is that okay? So now this becomes our f at x. Negative y squared over x squared plus f at x is now negative, okay, let me bring that, negative 1 over x minus y squared over 2x squared. Is that okay? So now plus c. This and that are like things, so we can add them together. Okay, you can do it yourself at that point. So from here you have negative y squared over x squared minus x minus y squared over 2x squared plus c equals to 0. So this one becomes our general solution. That becomes our general solution. So take this one and try it at your leisure time. So find the general solution of 3y squared plus 8t plus 2ty y prime equals 0. So try this and you can leave your answer in the comment section. Thank you very much for watching.